Yeah, hi everyone. So today I'm going to discuss one of the very important interview question. Uh, you can face question related to it, where we have to find out pole and zero for this circuit. For this circuit. So this is the circuit given, where we have one MOSFET, one cap, and two resistors connected like this. So after you can face question related to this, where you have to find out the pole zero and then the Bode plot of the gain plot or the phase plot. So here we will calculate the pole and zero without the complete small signal analysis in S domain, because here we have the capacitor, so we will have to use S domain to calculate the pole and zero, but we will not calculate here using small signal. We will calculate here directly intuitively. So how intuitively we do this? Just see here what we need to do. For pole, the simple method is calculate time constant for all independent capacitor. Here we have only dependent cap. Here we have only one capacitor, so we will have one time constant only and one pole. So here, and time constant for a capacitor is R equivalent into C, where R equivalent is the equivalent resistance across this capacitor. So how to calculate R equivalent here? To calculate R equivalent, we will remove the capacitor and ground the sources, and will ground the sources. So this is grounded here and grounded here. Capacitor we have removed. This is also grounded. Now from here across this is here is the capacitor. So this is ground, which means these two are connected. So this is in series. Here we will see infinite impedance. Here at the source of a MOS, when we see from the source of a MOS, we see the impedance 1 by Gm, where Gm is the transconductance of the MOSFET. So from here, what impedance we will see? 1 by Gm. From here it is Rs. So the equivalent R equivalent, if you will see, it will be this R and this R S, and this will be in series, because these two terminals are connected, and here it is coming like this, and this path is coming parallel. So it will be parallel infinite impedance of the gate, and then this will be plus, because this and this in series and parallel with 1 by Gm. This is in parallel from this node. This is parallel. So R equivalent will be 1 by Gm, because the lowest impedance among these is 1 by Gm. So R equivalent will be 1 by Gm. So tau, time constant tau, will be 1 by Gm into capacitor. So pole frequency omega p will always be minus 1 by time constant. So from here it will come minus Gm over C. Now we have to calculate the zero. So to calculate the zero in any circuit, to calculate zero in any circuit intuitively without going in S domain analysis or differential equation, because S domain, why we go into S domain? We have differential equation to make linear equation of that differential equation. We go to the S domain. So we will not use the differential equation, as well as we will not go to the S domain. We will directly calculate the zero, and we will not calculate the transfer function, we will calculate directly the 0. So what we need to do, just break every circuit, make it in two impedances and make it a voltage divider according to wherever is your, according to the output, where you have to find out the output and where is your gain. And to calculate the 0, so 0 is that frequency at which your output will become 0 while input is available. So this output can become 0 in two conditions. Either this become short circuit, means 0, or this become open circuit, infinite. When this will become short, this ground will be connected here, so this node will be 0, or this will be open circuit, so there will be no current, so this V out will be 0. So this is how you will calculate the 0 in every circuit. Now to break our given circuit into this form, what we will do, we will make it as a voltage divider, where this is our Z2 and this complete from here, because output is here, so this complete is our Z1. So this here is the V. So if we will see from here, it is simply Z1 and Z2. Now this Z2 can't become 0 because this is frequency independent. At any frequency this can't become 0 because this is frequency independent component. Resistor is frequency independent, while in this path we have capacitor which is frequency dependent. So at certain frequency this impedance Z1 can become 0, can become infinite at some frequency. So we have to find out that frequency at which the impedance Z1 become infinite. So now what is Z1 here? Z1 is simply, this is capacitor and this is source of MOS. Source of MOS means from here what is impedance? 1 by Gm. So 1 by Gm is in parallel with, these are two branches in parallel with 1 by Sc. So Z1 will be simply 1 by Gm parallel with 1 by Sc, which will be equal to 1 by Gm plus Sc. Now to become Z1 infinity, Zm plus Sc, this part should be 0. To make it Z1 infinity, it should be 0 from here. So to make it 0, the frequency S should be minus Gm over C. So this is our 0 frequency. So 0 is at minus Gm over C as well. Pole is also at minus Gm over C. So both pole and 0 are at same frequency and we have only one pole and one 0. So what type of transfer function it will have, what type of transfer function it will have all pass type of transfer function, because your here is your Gm, so both are same, so it will go like this only, because pole will try to push down and 0 will come back. So this, we call this pole 0 doublet as well, but there are some disadvantages of this as well in higher circuit theory, but you can avoid this for now. So this is how you can calculate without going to differential equation, without going to your S domain equations. Thank you.